atoms are composed of three subatomic particles, okay? Proton, neutron, and electron. Proton and neutron, they are found at the center of the atom, which is called nucleus. And electron, it is located outside of the nucleus, orbiting around the nucleus, okay? And majority of the mass of an atom, it comes from the nucleus, which is from proton and neutron. Electron, it has very little mass, but it takes up the most of the volume of an atom, okay? Proton, it is the identifier of the element. What does that mean? For example, the first element from your periodic table, which is hydrogen, right? It has one proton. The second element, helium, it has two protons. So it identifies the element. Proton, it has positive charge. Neutron, it is neutral, okay? Electron, it has negative charge. Now, this is the isotopic symbol of an element, okay? So what are isotopes? Atoms of the same element, it can have different number of neutrons. They are called isotopes, okay? So the bottom one, Z, is atomic number or the number of protons. The top one, A, is the mass number, which is the sum of proton plus neutrons. Now, here, the example, what's the number of proton? 11, right? The number of electron. Now, I want you to remember in all neutral atoms, the number of electron is equal to the number of protons, okay? So this is neutral atom, so it has 11 protons as well. Now, the number of neutrons, 23 minus 11, so it gives me 12. Atoms, it can gain or lose electrons, okay? If it gains the electron, the atom will have negative charge, and we call that as anion. If it loses the electron, it gains positive charge, and we call that cation. If it gains the electron, it is negative charge. That also tells me that atom has more number of electrons than the proton. If it loses electron, that positive charge, it tells me that this atom has less number of electrons in compared to the proton. And here is the example. What's the number of electrons in this particular oxygen atom? It has negative charge, that means it gained 2 electrons, okay? So it has 10 electrons. Here, it has 11 proton. It lost 1 electron, so it has 10 electrons, okay? Now here is the example. Now if I see the number of proton is 17, I will look at my periodic table. In the 17th element, there is chlorine, okay? The number of electron is 18, which is one number higher than the proton, right? So that means it gained 1 electron and it has 1 minus charge, 17 here. And the mass number, which is the sum of proton plus neutron, and it gives me 35. Another example, calcium 48. It is the isotope of calcium. Now, what is the atomic number, or Z? Now, I will look at the periodic table and I can see it is 20. Now, the number of proton is also 20. It is neutral atom, okay? So it will have equal number of electrons as proton. So the number of electrons will be 20 as well. This 48 is the mass number that goes here, okay? Now, what's the number of neutrons? I know this mass number is the sum of proton and neutron, right? So I can find the number of neutrons by subtracting the number of protons from the mass number, and it gives me 28. Another example, the number of neutron is given as 30 and the number of electron is given as 26, okay? In neutral atoms, again, the number of proton will be same as electrons. I'll write 26 there, and the atomic number is 26 as well. Now, the mass number I can find by adding proton and neutron, and it gives me 56. Now, The number of proton is 26, right? As I said earlier, proton is the identifier of the element. Now I will look at my periodic table, and at 26th position there is iron, and mass number goes here. Okay. Now isotopes and weighted average. The atomic mass that you see in your periodic table, that is the average mass of all the isotopes. Okay, so if we are given the percentage of isotope and their mass, how do we calculate the average atomic mass? There is a formula. Okay, so it is the sum of fraction of all the isotopes times the mass of their isotopes. Okay, one example is given. Copper, it has two naturally occurring isotopes. Copper 63 is 69.17% abundant. It has a mass of this 62.9296 gram per mole. And another isotope, copper 65, it is 30.83% abundant, and it has a mass of 64.9278 gram per mole. Now, what is the average mass of these two isotopes? Now, I want you to remember that the abundancy of the isotope, that should add up to 100%. Okay, 69.17 plus 30.83, it should be 100%. And if you change that to fraction, or if you divide that by 100, it is fraction, right? That should add up to 1. Now it is the sum of the fraction of isotopes times their mass. So here the first isotope, copper 63, it is 69.17. If I change that to fraction, I will get 0.6917 times its mass, this one, and I get this gram per mole. Another isotope, 30.83%, if I change that to fraction, it gives me 0.3083 times its mass. Now when I add this up, I will get 63.5456 or 63.55 gram per mole, which is the average atomic mass of copper. And that is what you see in your periodic table as well. Another example here, the average atomic mass is already given, okay, 69.723 gram per mole, and the mass of one isotope and the abundance of one isotope is given, and you will have to find the abundance and mass of the another isotope. Here abundance is easy, right? As I said earlier, the percentage, it should add up to 100%, so you can subtract from 100 and it gives you the abundancy of the another isotope. Now to find the mass of the another isotope, you can set it up like this. So this is the atomic mass, average atomic mass, which is given, okay, fraction of one isotope times the mass of that isotope plus abundance of the another isotope time x, and you need to solve for the x. Okay, so when I do this calculation, it gives me 70.924 gram per mole, which is the mass of the second isotope of this gallium. Okay.